How's it going? All good? All awake? Great. Okay, so hi everyone. I'm Gabriele. I'm an Italian software developer. By day, I run this little company in Milan. It's called Buildo. We do web applications using Scala and TypeScript. And by night, do a few things in the Scala community. I organize the Scala Italy conference, your best excuse to come to Italy in September 2018 in Florence, just saying. And the Milano Scala user group, I'm based in Milan, and we have a user group there. We try to meet every month. And when we succeed, it's great. And I do some Scala and JavaScript open source, including some maintaining Scalafix, helping all of you maintain Scalafix, which is the topic of today. So a little bit of agenda. It's rather a dense talk. So there's going to be a few things that I have to say in order to introduce you to the project and to what it means, Scalafix in the word of tiny word of Scala tooling. And then we're going to talk about ASTs very briefly. We're going to break it down to Scala Meta, and then finally Scalafix and some related examples. Okay, sounds good. So what is Scalafix? You probably heard it. It's like the go-to solution for any question in how are we going to do that? Well, Scalafix is going to provide a rewrite. So Scalafix is a tool, as you find in the documentations, for rewriting and linting in Scala. What that practically means is that you can automate migrations from one source code to another according to some rules that we're going to see in a few minutes. And also you can use this for linting. Essentially, instead of rewriting code, you just stop at some point, you emit warnings, and that's what we call linting. So once you have the infrastructure, it's pretty natural to go in that direction. So Scalafix is a project from the Scala Center. Scala Center, I don't know if you know it, is a center sponsored by many companies, including Lightbend, the PFL, 47 Degrees, and a few others that I don't remember. And the purpose is to do some open source work in Scala. And the process is there is a proposal, and the proposals are going to be accepted, evaluated by a committee, and are going to be prioritized. So Scalafix was actually the implementation of a proposal, which is the proposal to how to migrate automatically from Scala 2 to Dotty. So that was their answer to this proposal, Scalafix. We quickly realized as a community that Scalafix can do much more. It can be used today, not to migrate to Dotty, but to migrate across library versions, to migrate your source code into just removing some patterns that you don't want in your code base. So it's much more general purpose tool as of now. So that's what I was personally interested in the project, and we will see some examples of it. So speaking of examples, I just want to give you a glimpse of what it does, like out of the box. And so, for instance, this is a rewrite that is required by Dotty, for instance. The procedure syntax, if you know it, okay. If you don't know it, forget it, because it's going away. It's been deprecated since forever, probably 2013 behind the flag. And it's essentially, instead of writing colon unit equal, you can just use braces directly, and it interprets that as colon unit. No more, okay? So that was like a legacy syntax, so it's going away. So if you want to fix that, you can just pin up Scalafix and do Scalafix, no procedure syntax, and it does that for you. That's an easy rewrite. You could probably pull that off with a regex or something, okay? So, but this is kind of a syntactic rewrite, and it's the easiest thing you can do with Scalafix. Moving forward, there's a few things that are in the library already, like no auto-tupling. This was probably my first contribution to the library. And essentially, if you know what auto-tupling is, I hope you don't like it. I don't. Is essentially the compiler trying to be smart and adapting the arguments that you're passing in. So if you have like a tuple of 3 elements as input to a function, and you pass 3 elements instead because you're lazy and you want to spare a few keystrokes, it's going to tuple them for you and pass it on, and it compiles. So this feature has its purpose, but it's probably half-baked, and you can fix it with Scalafix. And I want to make you realize that this is not that you can do just by looking at the source code. You cannot just base yourself on the syntax here. You cannot just go around the add parentheses, whatever, whenever you find a function call. So you need to have some extra information. And Scalafix can do this because it's based on Scala Meta, and we will see how Scala Meta helps in providing the semantic information that are needed to do these kind of rewrites. So another example, just to prove that this is becoming a more general purpose tool, this is not in the library. Of course, this is not in the core of Scalafix. This is a specific rewrite for CAT, which is a library for category theory concepts. And essentially, there used to be a syntax, which is this syntax here, the TIE fighter operator, or the pizza operator, as Daniel likes to call it. And it's going away, sadly. We will all miss it. And the new syntax is like this tuple in which you invoke map n. So what you want to do with this rewrite, which is super tedious to write by hand, is to go around, replace all those things with commas, put braces, parentheses around it if you need it, and then take all the maps and make map n, and a few other things if you were doing that. So this is an example of a rewrite that is super, super inconvenient to do by hand. I mean, deprecating this syntax is essentially asking all people to go in every instance, and either you do some crazy editor macros or you're just done. You need to do this by hand. And it's pleasant to see that you can just download this rewrite. Scalafix will do that for you, compile it on the fly, and just run it on your code base. And this is already available. I mean, if you want to migrate from CATS 09 to CATS 1.0, you can just do it now, and you just pull the rewrite and do this and many others, specifically for CATS. So you can do third-party things, and you can distribute your own rewrites for your own library. And finally, this is an example of a linting rule, as opposed to a fixing rule, which does something on your code. So Scalafix can see the things that are being inferred, for instance. So in this case, if you want to prevent the product with serializable is ever inferred as a type of anything, you can do that with Scalafix. And this is already available in the core library. And it's probably a one-line fix in Scalafix, which is interesting. So the perspective that I want to give you today is about maintainers of projects, maintainers of internal libraries, maintainers of open source libraries, any kind of maintaining code and evolving code as opposed to users of this code, okay? It's not about the people, it's about the context and the situation of doing this process in which you want to evolve, but you want to break stuff, and users need to follow you along the way, okay? So if you consider maintainers, I try to draw a few levels of how good you are at doing your job as a maintainer, in quotes. So I need to draw a bottom line, and this is the bottom line. Like you break code, you release a new version, you don't tell anyone, you just break everything, okay? I hope this never happens or happens in past projects. I need to draw a line somewhere, but I'm sure it happens somewhere in the world, okay? Version 2 is out, everything is broken, goodbye. So slightly better is like you document what broke, here you don't tell how to fix it, which is weird, but it happens. And I consider equivalent when you link to a super long issue, like 300 comments. Oh, yeah, it's all there. Yeah, thank you. I don't have time for that, so I'm going to stay in this version. Okay, so this is probably as bad as not telling anyone what you broke. Slightly better, you break code that you document how to fix it, right? It's good. It's great. What's wrong about this is you usually don't give a choice to the users. So, hey, version 2 is out, and you need to do all these things before using the new features. So people are like, do I really want the new features and spend like 2 days fixing my code base, which is super huge, I was using all the old features, or not? Okay, so you kind of putting your users in a bad situation here, and it's not good, because as a maintainer, then you need to maintain the old version, because somebody's going to stay on the old version, and then it's Scala 2.10 all over again. And finally, this is probably state of the art as of today. Instead of doing what I just said before, you introduce a deprecation cycle. You're all familiar with that. It's very common occurring in languages. Like Scala had probably features that have been deprecated since like 2 or 3 versions. Like the procedure syntax has been deprecated behind the flag since like forever. But it's still there. It still works. And this allows users to move along with you, to start using the new features, and you just nag them like, hey, this is deprecated. You should really fix it because it's eventually going away, okay? Bonus points, if you also provide an automatic way of rewriting this, you get into the superhero kind of stage in which you can do this. Like you say, oh, users, here's a feature, I deprecated it for you, it's not broken, but if you want to fix it, it takes you 5 seconds, or compilation time, seconds. And it just does it for you, which is great. So am I talking sci-fi? Okay, aside from the technical, it's obvious that Scalafix can do some of this, but I'm talking like, is this actually happening in the world, apart from being technically feasible? Is that a workflow that is sustainable? So I don't only do Scala in my life. I get a chance to work on many other different technologies and communities. And I've been working in the Apple iOS/macOS community for a while. And if you ever spin up Xcode code recently, and by recently I mean the last 10 years probably, this has come up to you at some point, like, hey, there's a new version of Swift. Do you want to convert everything? Boom, shiny button that converts that for you. It's not perfect, but it does the heavy lifting for you, and it covers probably 90% of your use cases, and then you just fix by hands a few things, which is great. And the iOS community just moves really fast across new versions of languages and libraries, and Swift has essentially been released as a beta in 1.0. If you take a look at the breaking changes that have been from 1.0 to now, is crazy, and people are just fine with it. And also Apple blocks submission of old code, so well, that helps as an incentive. But in other communities where it is not blocking in any way, I mean, like Facebook releases React 15.5, new deprecation warnings, great, but also superhero, because there is this code mod called in JavaScript in which they can fix all your code base and move and remove all the deprecation warnings. And this is JavaScript. There's no types. They have to do some crazy hoops to understand what they're working on your code base in order not to break it. They're essentially reinventing a type checker every time they need to write a code mod. And that's sustainable, and that works. I mean, I work in the JavaScript community a lot, and the tooling is amazing in that sense, because people get on this train and start releasing code mod because Facebook is doing that. So if you're working on a testing framework like Jest, new version, new API, code mod, new version of that code mod, it's amazing. That works. It's there, and it's been working for years. So this is a quote from Olafur, which is the original author of Scalafix. I would say still the main developer, works at the Scala Center. And I was talking to him about this tooling, and he was like, wow, that's like crazy, amazing. He's the guy doing Scalafix. So I think we can do this leap. We can jump into the future. And so this is like the vision that we're pursuing. I'm into this because of this vision with Scalafix. So it's more like workflows and people rather than specific tools. The tool is just an enabler. So let's take a step back. As I mentioned before, I need to cover some material in order to make sure that people are on board when we're going to talk about Scalafix directly. Promise I'll be quick about this because I know most of you already know this stuff. So ASTs, who's not familiar with ASTs? Like, never heard of them? Okay, pretty much all of you are. So AST is after syntax trees. I just want to stress the fact that syntax tree is the easy part. It's very straightforward. It's a tree structure and represents the structure of a program as following the grammar rules. The thing I want to focus today is why abstract. Okay, so the abstract bit in the abstract syntax tree means that essentially when you're defining a val, what you care about here is essentially the fact that it's a val as opposed to a var, for instance, the fact that it's called answer, and the fact that the value is 42. That's it. You don't care about spaces, tabs, all the fun stuff we like to bitch about, the semicolons. You don't care about any of that when you're representing the structure if you needed to work on it. So that's why it's called abstract, because it ignores completely a series of concrete details that are specific of your code base, which a data structure doesn't care about. So it doesn't carry on the information of like spaces, not even comments in most cases, okay? So it forgets about that, which is both a feature and a dangerous thing if you're rewriting source back, and we will see that in a second. So why should we care about ASTs in general? So, well, this is Scala C, it could be any compiler. The first thing a compiler does is take your source code, interpret it into a data structure, which is usually an abstract syntax tree, and move on from there. Then it merges the node, it just does things with this node, annotates with information. It's the most basic thing, right? We need a data structure to do something interesting with a program because working directly with text would be crazy. Another similar workflow is macros. Like macros, again, this is an example of macro paradise, but it's a paradigm that works in any system that has macros. Macros is essentially a user-facing API that allows you to tweak these trees before they get fed into the compiler. So you can do your own thing, your custom thing, like generating a lot of boilerplate or, I don't know, doing some implicit crazy stuff. And then you move forward and you provide this to Scala C, and Scala C will happily compile that for you, maybe. Another workflow that is based on ASTs is Scala FMT, or any formatter for the matter. So if you go and look Go FMT, same thing. If you go and look at Re FMT for reason, it's the same thing. I mean, you just take your source code, you put it into an abstract syntax tree, and the idea is to normalize the output. So your code all looks the same, follows a style guide, etc. If you just want to do that, you can just parse it and print it, because it's going to forget all the stuff that I mentioned before. So you want to normalize white spaces versus tabs, parse it and print it. depending on how you print it, is going to look the same because it has no idea where it was before. So this is like a feature of it's forgetful when it goes up and down. Okay, so this is source code to source code, which is similar to what we do with Scalafix. But here the main impact is on the error, which is usually called a pretty printer. And the pretty printer is what determines how the code is going to look like. And if you want to add stuff like line length, like 80 columns, 100 columns, then it's going to get complicated and it's going to deserve its own project, which it is, which is Scala FMT. So Scalafix. So this is not a copy-paste. I mean, it is, but it's not exactly the same workflow. It goes from source to source, but with a very different focus. So Scalafix, so whenever you manipulate in trees, in macros, for instance, you don't see them back. Okay? You never print them back and commit them on GitHub, do you? Usually not. Scalafix, Scala FMT, those are tools that are visible in the output. So you really care about the output. So if you're only working with ASTs, for a formatter is fine. For a Scalafix-like tool, it could be dangerous. Like, take this for instance. This is fixing, although it's not super evident, but this is fixing procedure syntax, okay? Does that look okay to you? Okay, I kind of changed a few things. And the fact is that if I only have an AST, there's not much that I can do. I don't know how the original code was formatted. I don't know it was using braces for the block. I don't know it had a comment. I didn't know, so I just print it back. If you only give me an AST, I can only do my best effort to print it in a reasonable way, but it's not going to look the same as the original output. Okay, so that wouldn't be great for Scalafix. What Scalafix actually does is this. Okay, it just goes there and does the reasonable thing you would do by hand. So how can Scalafix be so precise and not invasive in what it does? So the trick is that Scalafix has access to more information than just the AST. It has access also to the specific tokens. So Scala Meta, which is powering Scalafix, provides the AST, yes, but also provides all the tokens connected to those trees. So you could technically print the source back as it was, including comments, including white spaces, including everything. And we will see that Scalafix works targeting trees, because trees are very convenient to find patterns that you want, but is helped by other information, and it outputs patches that patch directly tokens. So you go there, you actually insert a colon, a space, and unit as chars. You don't work with trees. You could work with trees, but the final API is much more low level. And the reason is that Scalafix wants to be surgical in this, wants to preserve the original code as much as possible, because that's the purpose of a rewrite, that is effective and is not throwing people off because it just formats all the code. Okay? So I'm saying this up front because when you see the API, you're going to be like, oh, I just want to manipulate these trees and print it back. But that's not going to scale if you're printing back a whole body of a def, because you're going to probably trim over comments and indentation, and users are not going to be happy. Okay? So, okay, let's do this. Let's take a break. Let's stretch for a second in case we, okay, this is like a gift break. You can wake up if you weren't following. Okay, I'm going to let this go for a while. It's hypnotic, right? Okay. So, new topic, Scala Meta. We want to talk about Scala Meta because Scalafix is essentially a tiny layer, a tiny API on top of Scala Meta, which is doing all the heavy lifting of providing all this information that we use to manipulate our programs. So Scala Meta, I need to do a couple of disclaimers about Scala Meta because Scala Meta is a meta programming library for Scala today. It was born as the new macro system, period. It is not the new macro system, period. Okay. I need to make this clear because it wasn't clear to me until probably a month ago because a lot has changed in the context of macros. So macros are now a separate project that the same author, Olafur, is working on for the Scala Center. If you're curious about that, go on the Scala Center website. There's a blog post explaining the roadmap. There's a lot of discussion on what is going to be in the new macro system, but the new macro system is not Scala Meta. So if you were expecting Scala Meta to be about macros, sorry, it's not going to be. You can use experimental annotation macros with Scala Meta, but they're not going to be maintained. We don't even know if we're going to have annotation macros anymore. So if you're curious about macros, look somewhere else. This is not about macros anymore. What metaprogramming is in the context of Scala Meta today is dev tooling. Okay? So dev tooling is a lot of things, which makes it even more interesting to me. And it's code formatting, code fixing, code browsing, navigating inside your editor, jumping to definitions, stuff like that can be done with Scala Meta. If you're curious about this, take a look at MetaDoc, which is a project based on Scala Meta that provides a read-only code browser online on a website. It's super, super interesting, and it opens a lot of possibilities. Other tools, I mean, internally at Buildo, we have a tool based on Scala Meta that does essentially parses Spray or Akka HTTP or DSLs and produces a JavaScript client out of it, which is nuts, but it works. And you can do many, many, many things with Scala Meta in the context of that tooling. And Scala Meta introduces a few concepts. It's essentially a data project. So it provides a lot of data structures. It provides a way of building these data structures, which is essentially constructor and parsers from source code to trees. And then it provides some really basic API for traversing these trees, but it's not the focus of the project. The project is very all about data. So we've seen trees. There's tokens, of course. Then it provides parsers. There's many flavors of the parser. You can parse pretty much anything that looks like Scala. Even the forks of the type level compiler you can parse. Any version of it is crazy comprehensive in the world of Scala dialects, SBT and such. As I said, a few manipulation primitives, and especially the semantic API. So the thing we're going to just look a little bit closer is the semantic API, because it's the thing that powers Scalafix the most. Okay? So semantic API, what do I mean by that? I mean, when you look at the code, you don't know everything. Okay? If you do like this, like list 1, 2, 3 up there, it could be anything. I mean, you are just assuming it's an immutable list, but it could be anything else. If you just do val list on top of your file, it's a different thing. It depends on the context. It depends on the imports. It depends on a series of things. So in the Semantic DB from Scala Meta, you find this information. So if you want to know what is list, like a fully qualified name of list, you can know it. So you can query for that name and look for its symbol. So the symbol is the fully qualified representation of a name. The name is list, and you can see that it comes from Scala collection immutable list. So you have a reasonable confidence that you're talking about the thing you think you're talking about. So when you need to do a rewrite, you want to target a list, you're sure you're not accidentally converting everything that looks like a list. Okay? So you can really be solid in your rewrites. Denotations is what we call for essentially metadata associated with this. So once we know that it's list in that package, that specific one we're targeting, you may want to know, okay, is it a class? Is it an object? I mean, list can be two things, right? It can be the class, or it can be the companion object. It could be a val defined in the source code somewhere. It could be anything. So that tells you that. It tells you whether it's private, it tells you whether it's protected, final, etc. Finally, an interesting thing that it provides, which is what powers the no-infer linting rule that we've seen before, is the synthetic. So the compiler sees more than you see in that source code. Actually, list 1, 2, 3 is actually list.apply square brackets int 1, 2, 3. And the apply and the square bracket with int are synthetic constructs that are inserted by the compiler at some point after the type inference has done. And you can actually query for those. So you can say, let me target the inferred type that goes here. And it has a position. It's like it's in the code. So Scala Meta exposes that for you so you can go and target it. So that's why, for instance, it was super easy to implement the no-infer linting rule. You just need to target any synthetic that is inferred in some positions. And that's it. It's one rule, one line of code. So with this in hand, we can move forward. And this is the gift break again, because we're changing subject. Taking a break again? Okay. So we can move forward to the Scala Fix API. So the Scala Fix API is very little, as a very contained surface. And it's essentially composed of a few concepts. So rule is not even an API. Your rule is a concept, is what you produce. So when you're doing some Scala Fix work, you provide a rule. They used to be called rewrites, but since we have linting, which is not really rewriting anything, we decided to call them rule. So a rule can be either checked or fixed. It's pretty intuitive. A fix actually does something. A check just emits a warning or an error. A patch is the result of a fix. So when you're fixing something, you're producing patches. So a patch is a patch in the diff sense of patch, in the sense that you're producing plus and minuses that you apply. So a patch is just a Scala representation that allows you to compose these patches and produce them, and eventually it just literally produces this git patch and that you apply to your source code. Rule context we will see in a second, but it represents the context of a single file. It's also friendly called kitchen sink because it has too many things. We're going to move things out of it. But yes, as of now, it has all the information about the source file you're working on. So the tree, the semantic information about that file, and the tokens of that file, and a few other utilities, and all the API to produce patches, which we will see in a second. Finally, we have this wrapper of the Semantic DB. Semantic DB, again, is just pure data dumped on a file. It's actually a protobuf encoding of this data fetched by the compiler. And Scala Fix provides some indexing on top of that. So it's faster to access the symbols and this kind of stuff. So that's why it's called index, but it's actually the same Semantic DB that I showed you before. So you can query for a symbol, you can query for a denotation, or for a synthetic. So yeah, that's what I said. Okay, done with the talking. I'm going to go to some live examples. And in case you have questions, this is a good moment while I get set up. Get set up. Okay. Okay, so what I want to show you today is how, if you want to start hacking on these things, what do you do? Okay. So first thing you do, you go on the website, okay? You have a flashy new website powered by SBT microsite. So you can go here in the rule author section. There is a setup section. And you can essentially use this SBT new template to provide a scaffolding structure that you can include in your library. So for instance, take this, okay? Suppose you have a library like mylib, or something, okay? So this ideally lives in the same library, in the same source, in the same repository as your library, okay? So suppose this is a library, I already have my setup here. I can just do SBT new. I'm gonna add quotes because it works like that on my computer, I don't know why. Okay, it just pulls this template and it provides the scaffolding for you. It's gonna ask you a few questions. Okay. Oh, demo effect. Of course it worked this morning. Wow, null pointer exception. Amazing. Okay. Really? For real? Come on. I swear it worked. Try again. Oh, I know what's happening. I don't have any connection. Okay, nice. Haha. I have a backup plan, don't worry. Okay, so backup plan. Let's go on an actual project that uses this. I use cats as my kind of a case study to see whether some rewrites were possible. So I have a cat repo here. So this is the whole project we don't really care about now. So there is a Scala Fix directory if you see there. So there is Scala Fix directory, and you can open this. So of course, when you do it with a template, it's going to be empty. So here we already have a few things, but the structure is going to look the same. So let's take a look at this. Okay, I'm going to write a few things, close a few things. Okay, so the basic structure of this thing is in 4 subprojects, 4 SBT subprojects. We really care about 3 of them. The tests one is only used as a glue to put things together. You don't really need to modify that. The ones you hear about are input, output, and rules. Okay? So intuitively, input and output are input and output of your rules. So what you can do is to have a whole project with a lot of examples of stuff you want to fix, and then you have an output project with the result that you're expecting. Okay? It doesn't match file by file. It's very naive, but it works. The cool thing about this is, for instance, if you're moving from a version of a library to another, you can have different dependencies on the 2 projects. So the input project, for instance, in the case of cats, depends on the 0.9, and on the input, and on the output, it depends on the RC or on the latest version, published even locally. And you can do this with any library that has 2 versions that you want to migrate, or you can do any other crazy stuff, like you want to migrate to a version when you have an extra library, you can do that. So it has a lot of flexibilities. And the rule project is when you actually author these rules, and you put the rules there, and we're going to see how you hook all of them together, okay? So let's try to do this. So I have a few examples here. We're going to add a new one. So this is the v1.0 folder examples. So let's add the Scala.io .scala examples. So I'm going to just copy paste this because I don't remember how to do this otherwise. So the rule we're going to apply is Scala.io. So you can use this header to tell which rule to apply to this input file. This is the same syntax of an actual config file that you can use in production, but bear with me. So we're going to use this package structure. It's OK. We're going to call Scala.io here. OK, so this is our input. As of now, we're not going to do anything with it. We're just going to copy this file to the output, identical. OK, we can just remove these comments here. It's useful only on the input. OK, and then we can provide a rewrite here, a rule. So it's going to be a case class Scala.io. It takes an index, which is the full semantic information, and it extends semantic rule, which is the rules that can work on semantic stuff, and it's called Scala.io. OK, so now we have to override this fix method, which takes a rule context and returns a patch. So that's the gist of it. You take a rule context, which represents a file, a source file, and you return a patch from it. OK? So let's go here in the terminal, SBT this. OK? So this is, when you start hacking on these things, this is where the template leaves you. It has a few debug informations, but you're typically staring at this and you're wondering, OK, what do I type? OK, that was the first time for me. So what do I type to see anything, to do anything? So the first thing you can do is to debug index this thing. So debug index is going to print the semantic information for the specific file. OK, the Semantic DB, the overall Semantic DB contains all your program. If you want to target a specific file, you just do context debug index. This is going to print the debug information. So you can do patch empty here. And let me just do one other thing. I think this is the syntax. Don't remember, this is going away. This is only a hack. So you can run tests on the test project. It's going to look at the input and output files. It's going to run the rewrite the rule that we just authored, and it's going to say whether it's OK or not, essentially. It's going to come from the output. So the output here is fine. I clearly have another output somewhere. Hold on a second. Yeah, 2 only. OK. So it just ran the Scala.io one, and it says that it's OK, because it's actually the same. So let's go in the input. Let's do a very silly rewrite. Which is, OK, I have a val x 43, I have a x 43, just to see that we're better than regexes. Then val, I don't know, z1, something like that. OK. Now, suppose your very noble target is to do +1 on everything. OK. So you want to do actually 44 and 2. OK. This is super boring, I know, but it's to get started with the API. So what do you do here? OK, so 99% of the time you're starting with a rewrite, what you do is to do context, tree, and this is a source file represented as a tree, collect. You never go wrong with this. OK, this is probably the most common API you use in Scalafix. So collect, it just partially matches on a tree. OK, it recurses on a tree and partially matches, is a visitor of this tree. So you need to match on something. So it's case something. How do you know what to match on? OK, you need to match on a Scala Meta tree, but how do you know which one? So a tool that is very helpful is this web-based application, which is called AST Explorer. It's a very handy tool that supports a myriad of languages, and it was originally born for JavaScript, and allows you to explore the source, giving a source its abstract syntax tree. I found it super useful, and with some crazy hoops, I managed to put Scala Meta support in this thing. It's through Scala.js. I'm still surprised it works, but it does. So what you can do here, you can go and type whatever you want, like x equals 43, and you can just hover on it and just click on it, and you're going to see here how the tree looks like. Okay, I'm going to hide a few things. So this is a lit int. So you can see the bigger picture. This is a definition of val, and has a patterns on the left, because you can put patterns there and do pattern matching, and then has a right-hand side, which is a lit int. So we're interested in this lit int. So you go here and you literally say lit int. That's it. Okay, so that's the tree you're matching on. So this is gonna give you all the all the literal integers in your source code. So first thing we're gonna do, let's compute the new value. So new value is going to be very originally t.value plus 1. If you're wondering where this value comes from, you go here, here's the value, okay? So now we have a new value and we want to put it back in the source code. How are we going to do that? So there's a few APIs for doing that. So the first thing you do is you go look at patch ops, which is on the documentation. And context extends patch ops, so it provides all the operations to produce patches. So the most basic one is probably add write. Okay, so we take in the literal, like the 43 or whatever, and we add into the right the new value, and then we take in that off. Okay, is that silly? I know, but it works. So what you do here, you add to the right of what? So add to the right of a tree. So next to the original tree, you add the new value as a string. Okay, and if you just do this, you need to do as patch, which essentially converts a list of patches into a single patch. This is another very common operation. But if you do this, we will see here in the terminal that this is going to fail, obviously, because we haven't done the right thing. But if you take a look here, you see there is 43, 44. Okay, so we actually added to the right of it. So now let's take that off, the original 43. So you concatenate a new patch with plus, and you can do context. You can do remove tokens, and remove tokens is going to remove all the tokens of a tree. So the original tree, you can take the tokens like this and just remove them. Okay. So after doing this, this is going to be green because we're doing what is expected. There's a few others API. You can just replace the whole tree by building a new tree. For instance, like doing the new tree is going to be lit int with this new value. And you can just do like context replace tree t with this new tree syntax. So you're printing this string as in place of that tree syntax. So as you notice, all these API usually work on trees, but they expect a string back. And that's what I was mentioning before. This is why it's weird. You would expect to return a tree and that imprints that for you, but you really don't want to do that because in most cases, it's not a good idea. But if you need to, like I did here, a lit in doesn't have any interesting information associated to it, so you can just produce a new tree and just call dot syntax on it, and it's going to pretty print it on the spot and just put it back where it is. Okay? So if you really miss manipulating just trees, just do dot syntax on it, but you're not going to like the results if you're working with a big tree. Okay? So another API that I want to explore, and then I think we're running out of time, is this. Okay, suppose, as I said, okay, this is easy because I already have the cat dependency here, so I want to just do this. So one of the few things that change in cat 0.9 to 1.0 is this. You have cat's, how is it called, data coproduct, for instance. Okay, so suppose you have a method, whatever, that takes an f, a g, and an a, and wants an instance of a coproduct here. So it's a coproduct of f, g, and a. Whatever. Okay. So turns out they rename coproduct. In cat 1.0, which is our output result, this is actually called cat's data either k. Okay. So this changes to either k, and you need to change the import. Again, not super hard to do by search and replace, but still, if it's something not unique as coproduct, or maybe you already have another coproduct in your code base, it's going to be painful because you really need to pay attention to the special cases, and you're probably not going to infer them syntactically. So how can we do this? So let's start this to make sure it works. Probably messed something up. Where? because I don't know Scala. Okay. That all right? Yeah, it's compiling. It's taking a while. Okay, perfect. So it's saying, okay, I want to IDK, you gave me a co-product. Okay, it says all the plus and minuses here in the diff, and you can see the actual result, which is identical to the previous output. So how can you do this? It turns out there's a very powerful API in Scalafix that allows you to do this. So let me just concatenate to the rewrites as before. You just do plus. So you can do context replace symbols. Okay, and you can just target that. So cats data either k, cats data coproduct to cats data either k. Done. Seriously. Okay, it just takes care of the imports. It takes care of renaming every time it finds an instance of this. Done. Okay, and it's not just replacing the, for instance, if you're going, I don't know, from either to Scala Z either, like the thing. Okay, if you do that, for instance, it's going to insert the import. It's not just going to replace the import. It's going to take care of, make sure that if you're using a symbol, it imports it if you tell him where it is. So this is a super powerful API. You don't even need, for this specific API, you don't even need to write a custom rewrite. You can just spin up the command line and do it in line. Sure, here. Out here in the output.
Right, okay, yeah, so, okay. I just wanted to see whether it was fully qualified.
Yeah, this API, the replace symbols API, it's a bit smarter than it should be, in my opinion, but it does a lot of, if you don't put like root at the beginning, inserts that for you. If you don't put dot in the end, which is the normalized version of the fully qualified name, it does that for you. But normally you would do the whole thing, so you can also write, so the full story would be to do this. Okay, so this is the fully qualified normalized version of this symbol. So you can do this. It actually does some heuristics to understand you did that, and it usually works. So as I said, you can use the CLI. You can just do, I don't remember the syntax now, but you can just do Scalafix, replace, and you do cats data coproduct to cats data either k, and you're done on the line on the spot without writing any line of code. So I'm gonna wrap this up because we are almost out of time. So what's next in Scalafix? My personal agenda is the first two lines. So I'm an open source contributor in my free time. So this is a project that is paid for by the Scala Center. So those two wishes may not align. But in my personal view, I would like to have more linter rules, like to unify some existing work, to contact the maintainers of existing linting tools for Scala and see whether we can collaborate and do a unified platform. So that would require also editor integrations, which is probably midterm as an effort. And rule bundles, which essentially is not having a huge file to download, but to have actually a structured project that you can download from GitHub and run on your code base. And then the last one is more like Scala Center focused work, which is robust expansion of inferred types. For some specific cases, there is not so robust. So essentially, that would be scoping information. So when Scalafix can insert explicit result types if you didn't do that, like for implicit, where like Dotty requires that you annotate, thank God, the implicit type, and implicit definitions needs to have an explicit type. Scalafix can do that for you, but it's not super smart at the moment so to disambiguate what's already in scope. So that's work in that direction. Medium term, as I said, editor integration and a more stable API. I mean, we're in the process of defining the API, and it's currently, as when you work, I don't know, with a design team and implementation, sometimes you speak two different languages because something that looks super easy is actually super complicated and vice versa. So that's the same with Scalafix as of now. Maybe removing a space is super tricky and renaming a symbol across the code base is super easy. So we want to go more to more predictable API. That's it. Thank you for listening. So if you have any questions, I don't know whether we have time. We have 5 minutes. Great. So please.
Yeah, first question. I wonder, I hope you didn't tell us in the beginning because I missed the last 2 minutes. But would it be possible with Scalafix replace the actual expression of the macro by the code it would have generated? Rewrite a macro usage, but the code to generate.
I get it. Okay, so the question is, can Scalafix actually expand inline the macros and just having them in your code base? I don't think Scala Meta support for macros is there now, in the sense that it doesn't give you that information to do that. So as many other answers to questions, I already know probably is going to be Scala Meta needs to support that first. So I don't think the Semantic DB can do this now. So as I said, Scala Meta is moving away from macros directly, and we don't even know what macro system we're targeting right now. So there's many. So it can technically be done if Scala Meta supports that kind of information.
How about the resolution?
How about?
How about the resolution?
Same thing, essentially. I don't think the support is there right now. We haven't worked in that area. And generally, type at point support is not there. It's not technically complex. It's just nobody had time to work on it. I mean, Scala Meta is essentially fully like free time work as of now, since Eugene is working at Twitter and the Scala Center is not directly involved into it, as only for like stuff that is blocking for like Scalafix, etc. But yeah, that would be exciting. I mean, that's definitely on the table. The whole structure is there to do it. Yes?
Is it possible to use Scalafix inside the deprecated annotation?
Inside, sorry?
Deprecated annotation. So in your IDE, you can see that the method is deprecated and apply a quick fix.
Yeah, okay, so that's a cool idea. And the question is, can you do Scalafix fixes based on the deprecated annotation, right? So absolutely, yes, that's a possibility. It's not there. There's no API to do that. But this is something we were discussing with Olafur. That would be great. If you have like a convention that if you deprecate with a specific message, you can also like instruct Scalafix on how to do it. So yeah, that would be a nice contribution. I mean, I think we have enough information to pull that off. Cool.
The question is, could Scalafix try to fix the code and if it doesn't work, backtrack?
Okay, so the question is, can Scalafix backtrack if it tries to fix it and it doesn't work? How do you define that it worked? It compiles? Okay, it's because sometimes you may end up with code that doesn't compile. So incremental things are not super supported in Scalafix as of now. I mean, even if you need to apply 2 fixes and intermediate fixes doesn't compile, it's currently not supported because we need to compile in order to go back. On the specific instance, I mean, it depends on what the problem exactly is, because what I do is compile and apply the Scalafix and then just look at the diff on Git and check it out. I roll back that. So if you want to apply, you would need to do that for single rules, or is it something that I missed? And then apply the next rules and stuff like that. That's essentially tooling at the level of the CLI or the SBT integration. I mean, it's certainly doable, but it doesn't do it right now. It hasn't been a use case for now, to be honest. But you can probably do that without touching the core. I mean, the core is what provides all the infrastructure that I said before. And then you have the Scalafix SBT plugin or the CLI that actually uses the core library to do that. You can do some kind of a backtrack strategy and try and compile and get it back. If you have a SBT plugin, you can do it pretty easily, I think. So yeah, sorry, most of the answers are, yeah, good idea, do it. But yeah, it's a 0 point something project. It's still not very mature in these use cases. Any other question? We're done. Okay, so I just want to point out, if you're looking for some kind of reference to start, the rewrites for the CATS project, as I said, were kind of my case study because they have a nice list of things that were broken. So I tried to fix them all. And so if you want to go look at that code, it's like a good reference guide. And the documentation is there and is becoming better and better. So again, if you're looking for an example, that's a good example. Otherwise, just grab me outside and I'll be happy to answer questions.